So we will start today. We will solve a system of two linear equations in a story problem. This is a pretty typical type of story problem you see for solving a system of equations. It's going to look like this. A company has a cost function, which is going to be C of x equals 8x plus 36,450. Don't let this problem freak you out. And a revenue function given by R of x equals 11x. X represents the number of items made and sold. Now, like all story problems, when you first see this, it's like, I don't want to do this problem. This looks very, very irritating. But actually what it is it's very similar to other problems where you have two equations and two unknowns. A couple things that make this problem look more grim are, it's got this really large number in it. That makes it look kind of nasty. There's no y's in it. There's using that function notation, C of x and R of x. And it is not immediately apparent how we're supposed to go about solving this. So what do they want to know? What they will usually ask for in a problem like this is they ask you to find the break-even point. But when they ask that, when they ask you to find the break-even point, when they're giving you a cost and revenue function, what they are actually asking for is they are asking for this. When does the cost function equal the revenue function? That is actually what they are asking you to do here. Is they're asking, when does the cost function equal the revenue function? So like most story problems that we do, the big thing is just figuring out what it's asking you to do. And then the math is not really any worse than any other problem. Because really what you're supposed to do to solve this problem, if they ask when does cost equal revenue, is you're supposed to set the two equations equal to each other and solve for x. Now, can we all solve that for x, especially if we're allowed to use a calculator? Yeah. I would just subtract 8x from both sides. And then divide both sides by 3. And if you do that, you'll get x equals what? Anyone packing heat today?
$12,150.
Okay. Now, what this problem tells us is it says x represents the number of items made and sold. So what we want to tell people is this. We will say this. If the company makes and sells 12,150 items, they will break even. What that means, everyone, is it means cost and revenue are equal when x equals 12,150. What are cost and revenue when x equals 12,150? Well, if you want to know what the cost and the revenue are, you have to take that number and you have to plug it back into either one of the equations. And they should give you the same answer, but for the purposes of this story problem, we will check it in both. So if you've got a calculator out, go ahead and try this. First, do 8 times 12,150 and then add 36,450 to it. And then do 11 times 12,150. This will tell us what the cost of making 12,150 items is and the revenue we'll generate from selling them. These should give us the exact same answer. What are we getting?
133,650.
So if a company has a cost function of 8x plus 36,450 and a revenue function of 11x, then if they make and sell 12,150 items, the cost and revenue will be equal at $133,650. Class. A second company has cost and revenue given by that cost and revenue function. The way the cost and revenue function are constructed, everyone, is very similar to the way they were constructed in the previous problem. I'm just using different numbers. What people often call this is they call this the fixed cost. The cost the company has to pay regardless of how many items they make. Maybe rent on their factory. What this 12 represents is it represents the variable cost or cost to make each item. What the 14 over here represents is the selling price of each item. What the question we often ask is this: how many items must be made and sold to break even what are cost and revenue at that production level? Everyone answer those two questions. How many items must be made and sold to break even? And what are the costs and revenue at that production level? Write down your answers. What do we think about that? I missed a 0 or you missed a 0?
I missed it.
Oh, okay. You cool now, though? You see it? All right. That's all right. That happens. That's why we practice in class. So a lot of people, as I said, will get freaked out when they see a story problem. They're like, I'm not even going to bother doing this story problem. But it turns out this one really isn't that bad. You just need to know the correct procedure. So we've got 2 cost and revenue examples here. The way this break-even point works is if production is above 18,000 items, we make money. If production drops below 18,000 items, we lose money. And for those of you who take business classes, this is a very simple model. It does not rely on supply and demand. This is a very kind of basic setup that's just telling us that if we make it, we will sell it. So if any one of you out there are thinking like, Steve, I'm a business major, it's a lot more complicated than this. Yeah, of course it is. But for the purpose of just understanding the math and seeing an application of this, we're setting 2 equations equal to each other, basically using the substitution method and solving for the variables. Questions or comments on that? Okay. Oh, here's something for you. Oops, did I just write that down? Make sure you can do this type of problem on the exam. I didn't really write that. Someone else, some lucky mathematical gnome wrote that. Okay. The rest of 9.1 is about 3 equations and 3 unknowns. What you're doing is you are finding what they call the ordered triple x, y, z, where 3 planes intersect. I have a picture for you. What we're going to have, everyone, is we're going to have these 3 equations that represent not lines, but these planes. You don't have to draw the pictures for these, by the way. Don't worry about drawing these yourself. I just want to show you what's happening. And what we're trying to find is we're trying to find where all 3 of them intersect. It looks something like this. You're trying to find a single point where all 3 of them intersect. And so it's going to be an x value, a y value, and a z value. We do not have to draw the picture every time. We're not drawing 3-dimensional pictures in this class, but I did want to show you roughly what this looks like. Another picture I got from my friend Charles in the math department. He's really smart. He gave me this one. I'm not sure if I realized I was so big. And there you can sort of see 3 planes intersecting at a single point also. So if you're trying to figure out what it is we're actually going to be doing during this part, this is what we're doing graphically, but we're not going to draw the graphs for this. Okay. So find the x, y, and z that work in all 3 equations. In Math 121, there will be 1 answer, which will be an ordered triple, or no answer, which will mean there's no solution. Those are the 2 things we're going to encounter in this class when we do this. Either we're going to get an ordered triple, we're going to get an x, y, and z that work, or we're going to find out there is no answer. You may or may not have done this before. Whether you have or not, maybe I'll show you a new trick or 2. everyone in here, and I do mean everyone, since you're all so smart, could easily find 3 numbers that work in that top equation. 2, 3, 5. It's easy to find. There's an infinite set of numbers that work in that top equation. Here's the rub, though, everyone. I need x, y, and z that work in all 3 equations. The number one way that people mess up these problems is they don't keep their work well organized. And they get all turned around with what they're trying to do. So what I did was I tried to write down kind of the technique I use for solving these problems. And this is not universal. This is not like something I'd publish in a book and say, this is the way you do this. This is the way that I'm going to teach you how to do it because this is the way that makes sense to me. We're trying to find the ordered triple that satisfies a system of 3 equations with 3 unknowns. We usually use the addition or elimination method for this. It does not come up very often that you use substitution with this technique or with these types of problems. Maybe you already know this, maybe you don't, but if you don't, this will be very helpful. You pick 2 of the equations, there's 3 of them. You pick 2 equations and you eliminate one of the variables by adding them together to get rid of one of the variables. Then you pick a different pair of equations. One of the ones you already used, one of them is the one you haven't used yet, and you eliminate the exact same variable by adding those equations together. What this will do for you is it will give you 2 new equations, each with only 2 of the variables, the same 2 variables in them. Then you eliminate a second variable. This makes much more sense after we do a problem, so if you're getting lost right now, make sure you read this later. Solve the final equation for the only remaining variable to get your first value. Go back to an equation with 2 variables and substitute your one known value to find your second value. Go back to an equation with 3 variables and we'll substitute your 2 known values to find your third value. Write your ordered pair, ordered triple, x, y, z, and check your answer on all 3 original equations. This sounds worse than it is. We're just going to keep our work organized. We're going to do this together and we're going to win. And you're going to be fine. You've got through enough in this class. You can get through rational functions and logarithms and all that. You can get through this. So, I didn't expect you to get all that copied down, but just know that's in your notes if you need to go back and reference it later. It's in there. And maybe you are already a whiz at solving these problems. If that's the case, you'll have no problem doing your homework. If that's not the case, then hopefully I can help you out a little bit today. It doesn't matter what you call each equation. I'm just going to call them 1, 2, and 3, but it really wouldn't matter if you called them 2, 3, and 1, or it doesn't matter what order they're in. What you do is you decide what variable you're going to get rid of, everyone. And what you look for is you look for 2 equations that you can add together as is and get rid of a variable. Now, does anyone see a variable that's just dying to be gotten rid of by adding together 2 of the equations?
X.
You can get rid of x by adding which 2 equations together?
2 and 3.
Say it again?
2 and 3.
1 and 3. Let's go 1 and 3. So I'm going to go 1 plus 3. Did you copy them down wrong?
Yeah.
That happens. And what this will do, everyone, is it will get rid of one of the variables for me. It'll get rid of the x. So I stack them like that. X is lined up, y is lined up, z is lined up, equals lined up, numbers lined up. The x's go away. I get 8y minus 2z equals 34. And I kind of put this equation aside. I kind of store that. I'm going to need that a little bit later. Now, we're going to pick 2 more equations and get rid of the same variable. So we can pick either 1 and 2 or 2 and 3. We got to pick a different pair. Another thing that helps you look for is even if you're going to have to multiply one of the equations by a number, it helps to look for one where one of them is negative and one of them is positive. Now we have to eliminate x again. So if we're eliminating x again, here's what I'm thinking I'm going to do. I will use 2 and 3 and multiply 3 by a 2. I'll use this equation and this equation, and if I multiply this third equation by a 2, then when I add them together, the x's will go away. Everyone cool with that? This is important. If this doesn't make sense to you, you're not going to enjoy this section at all. So here I go. I got 2x plus 4y plus 2z equals 30. And I've got negative x plus 7y minus 3z equals 24. I'm not going to do anything to that first equation. I'm just going to leave it as 2x plus 4y plus 2z equals 30. But the second equation, I'm going to multiply every single term in it by a 2, which will be negative 2x plus 14y minus 6z equals 48. I'm showing an excessive amount of work on this first one so you can follow it later. Add them together, and not only do we need to make sure a variable goes away, we need to make sure it's the same variable that we got rid of the first time. And once again, we are able to get rid of the x. Okay. Once you have gotten your two new equations, I would just sort of write those down over here. So now we have two equations with two variables. And the two that I have are 8y minus 2z equals 34, and 18y minus 4z equals 78. Now I'm allowed to multiply either one of those equations by any number I want, except for 0, before I add them together. And my goal here is to either get rid of the x, or the y or the z. It turns out you can get rid of either one of them, but to get rid of the y, you probably need to multiply both equations by a number. But there is a number you can multiply that first equation by, so you can get rid of the z's. -2. Very good. If you multiply this first equation by a -2, which you are allowed to do, you will get negative 16y plus 4z equals negative 68. Got to make sure you get all of them. And leave this one alone. And that was really smart to do that, because now we have a plus 4z and a minus 4z. Well done. Add them together. You will get 2y, the z's go away, equals 10. And I'll tell you, everyone, just so you know, finding the first one's the hardest. First one takes the longest, so we don't have to do this whole thing 3 times. What is y going to be, everyone? 5. Now you take y equals 5, and you plug that back into any equation you see up here, any equation you see anywhere that just has y and one other variable. So I will use 8y minus 2z equals 34. That has 2 variables in it. I plug in the 5. Because I don't want to mess up, I take my time. And I get z equals 3. Then you take y equals 5 and z equals 3. I won't circle that one. And you go back to any equation that has x, y, and z in it. What's the easiest one? 1, 2, or 3? Which is the easiest one that has x, y, and z?
1.
Yeah, the first one. X plus y plus z equals 10. So we do x plus y plus z equals 10. And that's going to give me x plus 5 plus 3 equals 10, or x equals 2. Meaning my final answer to this problem is 2, 5, 3. My claim is, and I know it's correct because I did this before class, my claim is that that is the only ordered triple that works in all three of them. What you should do in a testing situation for sure is check in the other two equations. When you're doing the homework, I know at this point you type in the answer, you hold your breath, and you hit check answer because you just want to be done with this problem, never look at it again. But definitely when you're in a testing situation, you got a lot riding on it, go ahead and you plug 2, 5, and 3 into these and make sure it works. This is not like checking with logarithms where you're going to get a bad answer by doing everything right. This is just a matter of making sure you didn't make a mistake. But I promise you they both work. So we win. It's over. First one always takes the longest because I'm always writing down the steps as I do the steps. Does anyone see a mysterious shadow up there or something they don't quite like? Let me kind of do this here for you. Did that first. Then I did this second. Oops. Then I did that second. Then I did this third. Then I did this fourth. This fifth. Yeah, that'll do it. And then my final answer was my sixth. Question?
When you plug the y equals 5 back in, did you use the original form of the segment?
It actually doesn't matter what you use. You use any equation that has y and z in it. So you could have used either of the original ones. Where were they? You can use either of the original ones or you can use the modified one. It doesn't make a difference. Any equation that has both y and z in it will give you the z value. That's the cool part. Just like when once you have your y and z and you're looking for x, you can go back to any equation you can find on here that has x, y, and z in it. Whether it's one you changed or it's one you left alone, doesn't matter. It's pretty cool. All right. So let me make a note of that. That procedure is called back substituting. So when back substituting to find your second and third value, you can use any equation that has the appropriate variables. All right. Here's what that looks like, everyone. This is not something we're going to make a habit of. I tried to draw this one online. I found a program. Here's what we just did. This was the better of the two pictures I got. We got three planes, and we just found the point where all three of them intersect, which is actually right around here. That's why we don't draw the pictures of that. If you're interested in three-dimensional stuff, they do a lot of that in Calc 3. That's where you do a lot of three-dimensional math, which is pretty cool. But that's what we just found. All right. If you are trying to find an ordered triple and you ever encounter a false equality, such as something like this, if everything starts canceling away and suddenly you're looking at something like that, 0 equals 4, that means there is no solution. There is no combination of x, y, and z values that satisfy all 3 equations. So you don't need to guess ahead of time if there's going to be a solution or not. What you do is you just start doing your procedure. And if during the course of the procedure you ever end up with something where like everything goes away and you just have like 0 equals 4, and you're like, well, that isn't even true, that just means you're done and there is no solution. And that should be one of the choices when you're doing the homework. There should be like a couple choices, and one of them should say, put your ordered triple here, and then there should be another choice that says, there's no solution. So either you are giving an ordered triple, like 2, 5, 3, or you're going to say no solution to this system. You will encounter problems. Where it is best to multiply both equations by different numbers. Do not be alarmed if when you're doing a problem you end up in a situation like this. And you're trying to get rid of one of your variables, and you are forced to maybe multiply this top equation by a 5 and this bottom equation by a 3, giving you 15x plus 10y equals 35, and negative 15x plus 27y equals 36. So do not be alarmed if when you're doing your homework, you have to hit both equations with a number in order to get rid of one of the variables. Do not finish this. It has nasty decimals for answers. Do not finish that. That was just me making a point that don't be afraid to hit both of them. Now, the reason we do that, the reason we hit both of them rather than one of them, is because if we hit both of them, we can avoid multiplying by a fraction. There is a way to do this by just multiplying one of them, but you have to multiply it by a fraction, and it gets needlessly messy. It's much easier to do it this way. So please don't think ever that you're not allowed to do this. You can do that, and you probably will do that on some problems. All right. What else can happen? Well, we can get answers that aren't very nice. You know, class, I'm not going to tell you there's only one way to do this problem because there's lots of ways. Someone could do this by eliminating x first, someone could do it by eliminating y first, and someone else could do it by eliminating z first. and everyone could get the correct answer. Everyone could get the correct answer. But what you want to do is you want to do a little bit of scouting before you start trying to get rid of variables. And you want to look for the easiest way to get rid of a variable as possible. You want to look for numbers that are multiples of each other so you can easily multiply them and get rid of a variable. For instance, if I multiply this top equation by -3 and added it to this bottom one, I can get rid of x. If I multiply this second equation by -3 and add it to this bottom one, I can get rid of x. And that'd be how I get rid of x. Can I do something with the y's? I can multiply this second one here by a 2, add it to that one and get rid of the y's. I can multiply this second one by a 3, add it to that one and get rid of the y's. Z's look a little bit trickier. I guess I could multiply this one by 5 and add it to that one. And then I can multiply this one by -2 and add it to that one. So anyone can do this any way they want. There's no right or wrong way to start. What I chose to do, and I'm going to do it just because I have it in my notes, is I chose to eliminate y first. You are more than welcome to try doing another variable first, and you will get the same answer if you do all your math correctly. So here's what I did. I took equations 1 and 2. 1 and 2, 2x plus 6y minus z equals 7. So I'm going to ask for right now, if you want to play along with me, that you all eliminate the same variable as me. And what did I do to eliminate y? Before I added them together, what did I do? If I want to eliminate y by adding them together, what's the easiest thing to do here?
Multiply equation 2 by 2.
Multiply equation 2 by the number 2. Everyone see that? So we'll leave equation 1 alone. And this one we'll do times 2. Make sure when you multiply the equation by a number, you get every single term. Then you add them together. You get 6x plus 9z equals -7. Now, since I chose to get rid of y the first time, I got to get rid of y the second time. Otherwise, I'm just going to be going in circles. So now I'm going to use equations 2 and 3. Equation 2 is 2x minus 3y plus 5z equals -7. Equation 3 is 6x plus 9y minus 2z equals 12. You might be seeing at this point why the number one mistake I see people make on these problems is not that they can't do the math, but they just don't keep their work organized and they lose track of what they're doing. It can happen to anyone. Everyone, see if you can multiply one of those equations by the appropriate number and add them together so you can get rid of the y's. Multiply one of those equations by an appropriate number, so when you add them together, the y's go away. You can do this. You should be getting 12x plus 13z equals -9. Are we winning or losing? Questions, comments? Take your two new equations, this one and this one. And then decide which one is going to be easier to get rid of. x or z. I could get rid of either one of them. By multiplying both equations by an appropriate number, I could easily get rid of those z's, but it's going to be a little bit easier to get rid of the x's. Why? Why can we get rid of x's more easily? Sorry?
6 times 2 is 12.
Yeah, so we just multiply that top equation not by 2, but by negative 2. Gotta be very careful when multiplying a negative number, because you gotta make sure you change the sign on everything. Very, very easy to mess that up. Whew. Made it. It is possible, like it will be on this problem, that you are not going to like the answer and be sure you're getting it wrong. Everyone knows that every now and then you will encounter a homework problem that has fractions in it. Now what I need to do is I need to take that z equals negative 1, and I need to find any equation that has both x and z in it. Fortunately, those are both right here. So I'll just use one of those. I'll do 6x plus 9z equals negative 7. So it's going to be 6x plus 9 times negative 1 equals negative 7. And sure enough, 6x minus 9 equals negative 7. Add 9 to both sides, 6x equals 2. I get x equals 1/3. And try as you might, that is what you're going to get. You're going to get a fraction for an answer. Go back to the original problem to find an equation with all 3 variables. It doesn't matter which one you pick. Pick the one you want to use. I did the last one. I did 6x plus 9y minus 2z equals 12. At the moment I couldn't tell you why I picked that one, but that's one I picked. Oh! The reason I picked that one. Oh, there is a reason I picked that one. Why did I pick that one? I'm plugging in x equals 1/3. Why did I pick the last one? Because 6 is divisible by 3. I knew there was a reason I did it. Yeah, so I picked this one because 6 will kill the 1/3. Give me 2 plus 9y plus 2 equals 12. Give me 9y equals 8. And y equals 8/9. So my final answer is 1/3. 8/9 negative, just negative 1. Now let's say you were in the middle of a test. This was the last problem you had to do on the test, and you had 15 minutes left. What you should do is you should not leave early. You should check your answer in the other 2 equations, or just one of them at least. But you don't need to sit here and think, I wonder if I did that right. Because if you plug it into either one of these, you will see that it gives you a true statement. The beauty of these problems is you can be absolutely sure that you got it right or wrong by checking your answer. You know, graphing a rational function after you're done graphing, you're like, well, I hope I remembered how to do that right. But one of these, you can check it, you can see, and they do both work. So this is our correct answer. Who's exhausted? Let's take a break. I'll see you at 11:32. occasionally, it is possible you will encounter a problem where all they ask you to do is check the answer. They say, we already found it. Does it work? If you check an answer, you do need to make sure you check it in all three equations. And if it fails in any of the three equations, it is no good. The reason I bring that up is because with this first one here, when you take that 3, 2, and 5, and you plug the 3 and the 2 into this first equation, negative 3 plus 2 is negative 1. It looks like it's going to work. But then, when you go to the second equation, you plug in 2 minus 5, you do not get negative 6. I want to write an X, you'll get that confused with the variable. 2, what was I doing? Lost track of everything. 2 minus 5 does not equal 6. So once you get a bad answer, it doesn't matter if it worked in the first one, it doesn't matter if it works in the third one also, you just know right off the bat, no, doesn't work. That one's no good. This one over here, 3, 2, negative 1, you do need to make sure you check it in all of them. So it's going to be negative 3 plus 2 equals negative 1, check. It's going to be, did I copy this right? Losing my mind. No, I didn't. 1 second, everyone, I'm losing my mind. This should be, oh, I did copy it wrong. Everyone. This should be negative 4. I wanted this second one to work. The second one should be negative 4. 3, 2, negative 4. Not 3, 2, 5, but 3, 2, negative 4. Okay, still works in the first one. Then we do 2 minus negative 4 equals 6. It works in the second one. And then we do 3 minus 4 equals negative 1. It works in all three, so this answer is valid. Sorry about that, everyone. So that one does work. So if you're ever asked to check an answer, what's the rule? Check it in all three. And if it fails in any of them, it's out. All right. A couple notes for you. In 9.1, keep your work organized. Check Steve's steps if you're lost. You will need to do 3 equations and 3 unknowns on the exam. There is not a problem on the exam like number 14 in the 9.1 build understanding homework. So you will need to do one of these on the exam. With the 3 equations and 3 unknowns, take your time, go through all the steps, and find the ordered triple. You will need to do that in the test, I promise you. So make sure you practice that when you're doing your homework. But when you're doing your homework, the very last problem, I believe, in 9.1, problem number 14, is a story problem. I did not put one like that on the test. So do it so you can get the homework credit, but don't spend your whole weekend worrying about it because you think it's going to be on the test, because I didn't do that one. Okay, that's it for 9.1. Any questions, comments, concerns? These you just need to practice so you can keep your work organized on the test and nail it. 9.5, back to 2 variables, but one or both equations will not be a line. This means we can have more than one answer. In 9.5, you're going to be back to x and y. No z in this one, just x and y. You're just going to have two equations. You still got to find the x and the y value that work in both. However, there might be more than one correct answer, because if one of them is not aligned, or both of them aren't aligned, we could have graphs hitting each other in more than one spot. For instance, if you had a circle and you had a line like that, you could be looking for two answers. Does everyone see that? Two correct answers. So the answer here would be two ordered pairs. In 9.5, you should always check your solutions, and your solutions will be ordered pairs, in both original equations. In this section, you should really check all your answers. And there's just two equations to check them in. But you should really check them both, just to be on the safe side. This is a problem from section 9.5. What you will notice is they're not both lines. The first one's a line. What's the second one? Yeah, circle, well done. We have a line and a circle. Let's warm up with this problem. Here's my question to all of you. Find the ordered pair that satisfies both equations. Oops, what happened? Find the ordered pair that satisfies both equations and has x value 3. Oops, it's not 0. In other words, they're giving you the x value. Now, this is a tip from Steve. Once you know one of your values, like x equals 3, find the other in the simpler equation and check it in the more complicated. That is a tip from Steve, everyone. If you know one of your numbers, if you know either the x value or the y value for your answer, the best thing you can do to finish the problem is to use the simpler of the two equations to find the other value and then check it in the other one. So of those two equations, which one's simpler, the line or the circle? The line, it doesn't have any squaring in it. Does everyone agree with that? So what you do is you take that 3 and you plug it in there. And what will you get? Y equals, yeah, good, everyone. 8 minus 3 is 5. It's also the third to last day of class, so that's fine. Y equals 5. And then what you do is you claim your answer is 3, 5. Then you check that answer to make sure it works in x squared plus y squared equals 34. Then you check it in the second equation, the harder equation. Is 9 plus 25 equal to 34? Yes, we're done. The other solution to this problem is 5-3. 5-3 actually also works. The reason I know that 5-3 also works is because I noticed that the positions of x and y are totally interchangeable. This is what it looks like. These pictures are easier to understand because they're in 2 dimensions. This was number 1. There you are. Oops. I really need to shrink these before I come to class. As you can clearly see, holy cow. And now it's all distorted. That is a circle, everyone, not an ellipse. It's just a distorted circle. But right here is the ordered pair 5-3, and right here is the ordered pair 3-5. Okay. Everyone kind of understand what we're doing in this section? We're going to try and find places where 2 functions intersect. One of them might not be a line, so we got to make sure that we look for multiple places. All right. Let's try this one. All answers are still ordered pairs with the x value first and the y value second. You will use both substitution and addition/elimination. Both of those techniques are going to come up in this section. Now, maybe they're not written the way we like them to look, but if we have an equation with a y and an x squared in it, where did we see x squared? What did that give us? What shape did x squared give us? That's a parabola, yeah. We have a parabola, and we have a line here. We're going to find out where this parabola and this line intersect. Now, think back to what I said about substitution on Tuesday. Substitution works really well if you can solve one of the equations for one of the variables without fractions. So what we want to note is this. Y equals 2x plus 4 is already solved for y. So plug 2x plus 4 into the other equation for y. That's how substitution works, everyone. This one already has y equals 2x plus 4. So if we take this equation right here, we can rewrite it as x squared equals 2x plus 4 minus 1. Because y equals that, and y is right there. It's still the same game as before, everyone. Solve for one of the variables, get one of them, and then find the other one. The problem is, how do I solve this quadratic for x? How do I get x all by itself? What do I do? Or how do I solve for x? Say again? I could square root, but that's not actually going to get me any headway on this one. I got to do something else. Does anyone remember how we solve for x in this type of problem? When did we do this last?
Logs.
We don't get to do logs. We don't need to use logs because there's no variables up in the power.
Completing the square?
We could complete the square. We could complete the square. We could also just get everything on one side and hope we can factor it. Now, completing the square is a very good idea, but if I can avoid completing the square, I'm going to. So what if I just do this? Can we factor that? Set equal to 0 and factor. Who can factor that?
-3 + 1.
Very good. Awesome. And if those are your factors, what are your two x values? 3 and -1. Is it okay that we got two x values? Yeah, because can a line hit a parabola in more than one spot? Yeah, it can. So we take these, 3 and -1, and we find the y values in the simple equation. What's easier to work with, a parabola or a line? A line. Y equals 2x plus 4. So we got y equals, 2 times 3 plus 4. And we went y equals 2 times -1 plus 4. So if I put the 3 in there, I'm going to get 10, which means I get the ordered pair 3, 10. If I put the -1 in there, I'm going to get a 2. So I get the ordered pair -1, 2. After I find my y values, what do I do?
Plug them in for the correct x value, or put them in the correct spot for the x value.
Good, and the y value, right?
Yeah.
So here's what I'm going to do. Now, check in the more complicated equation. Once you find your answers with the more simple equation, you check them in the more complicated equation. So we found our x values through substitution. We plug the x values into the simpler equation to get the y values that go with them. Now we have our two answers. Now we check them in the more complicated equation. So we check 3, 10, and we check -1, 2 to make sure they work. We make sure that 3 squared equals 10 minus 1, and we make sure that -1 squared equals 2 minus 1. Are those both true? 9 equals 10 minus 1, and 1 equals 2 minus 1. So when all the dust settles, these are our final answers. Yeah, I would say, yes, you do check them in both. You do check them in both. But I would say a more important thing to remember is this one right here. Where is that? Where did I put that? Oh yeah, it's the hot tip. Once you know one of your values, like x equals 3, find the other in the simpler equation and check it in the more complicated equation. This one looks like this. Got another huge drawing here for you. Oh yeah, this one's really tall and skinny. This is going to look great. So big. There it is. So, is that the right one for this one? No, that is not the right one. Everyone, I'm eating up valuable time right now. Look at this. Go away. All right. That's not the right one. This is the right one. That's it right there. Because right here is the ordered pair 3, 10, where the line hits the parabola. And right over here is the ordered pair -1, 2, where the line hits the parabola. Okay. Let's have you try one. Pretty similar to the one we just did. It's going to be pretty similar to the one we just did. Now you go ahead and get started on that. For those of you who get really stuck, I'm going to do it slowly up here, so you don't just have to sit there and do nothing. So if you get stuck, you can look up at the board. But see if you can find all intersection points. Find all the places where those two things intersect. So get started. This one's a little trickier than the one we just did. I just realized that when I wrote it up here, it's a little bit trickier, but you can still do it. Does everyone have it copied down so I can start working it up here? Okay. I found my two x values. If you want to look up here and make sure you found the same two x values I did. I had to use substitution. I had to mess a little bit so I could get rid of a negative sign. And I did some factoring. Did everyone see to do the substitution on the first step because the first equation was y equals x squared plus 7x? And you can plug the x squared plus 7x into the second equation. Once you do that, you got to distribute that negative sign. And then, because I don't like having a negative x squared, I'm going to try to have a positive x squared. I move every term over to the right-hand side, so it would be a positive x squared. Positive x squared is a lot easier to factor than when you have a negative x squared. Obviously, these are harder than the ones where they're not, when they're both lines, because you're gonna be looking for multiple answers, and you don't always know how many answers you're looking for. But as long as you use one of your two equations to find the answers, and then use the other one to check your answers, you should be in good shape. This one, actually, some of you might have thought it was easier to find your two answers using the parabola, because it was already solved for y, but you should have got the same answers as me if you did that. So everyone should be getting 330 and -70 for this. I don't expect you to walk out of here thinking I don't even need to do the homework because I already get this perfectly. But does anyone feel like there's a secret I'm keeping from you that I can help you with? All right. Let's do one where you actually use the addition/elimination method. They're not very friendly looking because of the format they're written in. But what we have here, everyone, is we actually have an ellipse and a hyperbola. I actually have an ellipse and a hyperbola here, and we're going to find out where they intersect. This one, I think it is actually easier to use the addition/elimination method to just kill off either the x squared or the y squared, just as though you would if they were just x and y. So what I'm going to do, everyone, is I am going to multiply first equation by 3 and the second equation by 5. I'm going to multiply the first equation by 3 and the second equation by 5. Here's why. That's going to give me 9x squared plus 15y squared equals 51, and 10x squared minus 15y squared equals 25. Will that help me out at all, what I just did? Yeah. Could someone else have said I'm going to multiply the top equation by a 2 and the bottom equation by a -3 and get rid of the x's? Yeah, you could have. Yes. Either way, though, if you want to avoid fractions, you're going to be multiplying both equations by some number. But could eliminate x with a -2 times the top and a 3 times the bottom. That would work just as well. But I add these together, I will get 19x squared equals 76. Oh, that's kind of grim looking. I wonder what 76 divided by 19 is. What is 76 divided by 19? 4. Oh, that's not so bad. X squared equals 4. Now don't lose track of what that means, everyone. This is not asking me for the square root of 4. This is asking me what numbers could you square to get 4. Not only 2, but -2. Because to solve this for x, you actually apply the square root property. So you're actually going to get 2 answers, plus or minus 2. So I have 2 possible answers here, 2 and -2. So plug x equals 2 and x equals -2 into either original equation. The reason I say either is because I'd say they're both about equally complicated. So my original equations, I guess I'll do the ellipse. So I got to plug 2 and negative 2 into this sucker. Anyone want to tell me anything about plugging both 2 and negative 2 in? It's going to be the same answer because the first thing you do to that 2 or that negative 2 is you square it. Does everyone see that? So for both of these, what you're going to end up with there is a 4. So you're going to end up with 12 plus 5y squared equals 17, or 5y squared equals 5, or y squared equals 1. Don't rush this. You don't get an answer of 1. What do you get? Plus or minus 1. So, class, I get y equals plus or minus 1. So, when I plug in x equals 2, I get y equals plus or minus 1. When I plug in x equals negative 2, I get y equals plus or minus 1. Anyone know what that means?
Intersects in 4 spots.
What's that?
It intersects in 4 spots.
Yeah, 4 spots. What are they?
2 positive 1, negative 2, negative 1, negative 2 and 1, and 2 and negative 1.
Is he right? Can we be sure about that? Yeah, we can be sure. We just check it in the other equation. And don't worry, you don't have to check forwarded pairs, because whether or not you plug in a plus or minus 2, or you plug in a plus or minus 1, you're going to get 8 minus 3 equals 5. This thing had 4 answers. Has 4 answers. Our final answer to this problem is, in any order, now, before anyone makes a mistake on the test, which will not cost you a ton of points, but would cost you 1 or 2 points, let me make something very clear. This is not correct. The reason that is not correct is not because I'm a jerk and I don't want you to use shorthand. It's because this actually means just those 2 answers. It does not imply that you're allowed to do the mix and match. That one implies 2, 1 and negative 2, negative 1, so you're losing half the answers if you do that. Technically, what is correct, but I wouldn't recommend trying to memorize this, would be doing this. This actually is okay. Flipping one of the plus minus overs. That's all right, actually. But I wouldn't do that. Rather than sweat on the test and say, I'm wondering if I'm doing this right, just do this. That's the best answer to give.
What is the flip?
The flip means that they pair off differently. So this means positive 2 pairs with positive 1, negative 2 pairs with negative 1. This means positive 2 pairs with negative 1 and negative 2 pairs with positive 1. So that actually is correct. But not really worth it. What else do we need to know? The math homework asks for all solutions, including non-real complex solutions, which is just a fancy way of saying imaginary numbers. None of your homework problems have imaginary answers. So you can just ignore that. The instructions are in there, and I couldn't do anything to get rid of the instructions that say that, because there are some problems for people that are taking like a pre-calc class that have imaginary answers in this section. You don't have to worry about that. So when you read that in the instructions, and it says like find the imaginary answers also, none of yours have imaginary answers. So don't worry about this. Oh, real quick. I got a picture of this one for you. There it is. That's the one we just did. Kind of cool. I don't think you're going to find any of them more than 4 answers. All right. Just as we're finishing up here, everyone, because I realize this last example is probably going to take us right to the end. That's okay. This is the last one I wanted to do with you. Everyone knows that Tuesdays are review day, right? Everyone knows where all the resources are on D2L. You can find everything. Can't find anything, shoot me an email, this afternoon before 4 o'clock. I'll help you out. We got to find where this line intersects this, which is an ellipse. It doesn't look like a really friendly ellipse. And you can do this even if you don't identify the equations. I just like to do it for your notes. Addition is out. Because one equation has x squared and y squared, and the other has x and y. So we can't add the equations together to get rid of a variable, so that's not going to work for us. So we're going to have to use substitution. And that's the point I was trying to make last time. I'm never going to tell you which way you have to use, but sometimes you will have to use one way just because the problem dictates it. Using substitution means we need to get one of the variables all by itself in one of the equations. Fortunately, that second equation lends itself to that. Because with that second equation, can we get either x or y by itself pretty easily? Yeah, I can actually get x by itself really quick. Because all I have to do is add y to both sides, and I'll get x equals y minus 1. So I can now substitute that into the top equation. So what's that going to be looking like? That's going to be 3 times y minus 1 squared plus 2y squared equals 14. All right. Everyone okay with that so far? Let's see here. Got to FOIL this. Got to distribute the 3. And what I have here is a quadratic. It just happens to be a quadratic with y as my variable because I chose to keep y's around. So I guess I'll get everything together on one side of the equation. So that's going to be 5y squared minus 6y minus 11. That's what you'll get after you collect like terms and get everything on the same side of the equation. Well, I'll tell you, class, you can actually factor this one. And normally I'm a big fan of completing the square over the quadratic formula, but the quadratic formula might actually be better on this than completing the square. But you can factor it, and factoring something like this is not necessarily the worst, and I'll tell you why. 5 is a prime number and 11 is a prime number. So you really can't break them up that many ways. That means we have to have 5y and y, and we're going to have 1 and 11. So if you put the 11 here and the 1 here, you put the minus there and the plus there, that actually will factor that. If you can't see that, and I wouldn't blame you if you couldn't, because that's a rough factor, you can find it with the quadratic formula, you can find it by completing the square. But the reason I'm doing this problem last is because, yes, indeed, we do get 11/5 and -1 as our two y values, and we have to use those two y values. So we take y equals 11/5, and we take y equals -1, and we plug them back into the simpler of the two equations, which in this case is x minus y equals -1. So that's going to be x minus 11/5 equals -1, and x minus -1 equals -1. This will give us x equals -2, and the other one will give us x equals 6/5. Gross. But it's also gross if I do problems in class that never have fractions, and then you go do the homework and you encounter one with fractions. You're like, why didn't Steve do one of these for us? So my claim is that my two answers are 6/5, 11/5, and -2, -1. But before I close the shop up and say those are my two answers, what do I do to check? That's not a very... What do I do to check? I check. Oh, class, what fun we have in here. I mean, math is just so much fun. We check them both in there. 3 times -2 squared plus 2 times -1 squared equals 14 is going to end up being 12 plus 2 equals 14. That one's awesome. 3 times 6/5 squared plus 2 times 11/5 squared is supposed to equal 14. That's 3 times 36 over 25 plus 2 times 121 over 25 equals 14, which is going to be 72 over, I'm sorry, it's not going to be 72. It's going to be 108 over 25 plus 242 over 25 equals 14. 108 plus 242 is 350 over 25 equals 14. What's 350 divided by 25?
14.
Heck yeah, it is. As we close up for the day, because it is 12:19, we will say that our final answers are 6, 5, 11/5, because it checked, we got it in one and checked in the other, and -2, -1. I will wish you all a happy weekend and happy studying, and I will see you for our review day on Tuesday. Here is the picture of the problem we just did. Study hard, everyone. We got 2 days of class left. Review and the final. I'll see you on Tuesday.
Last day is Wednesday then?